Now let's get started on lesson 3. This box right up here at the top pretty much summarizes what we did in our notebooks, reminding us of this law that if we have x to the m raised to the nth power, we can multiply those exponents and we get x to the mn. That's what we learned in our notes. Let's do a couple exercises together. Right here we have 15 to the third raised to the 9th power. To do our work here, we don't need to come up with an actual answer, but we do need to show our work. We would get 13 to the 3 times 9, which would equal 15 to the 27th, which would end up being a huge, huge, huge number. All right, let's go ahead and try this again. Here we've got negative 2 to the 5th power to the 8th power. So here we've got negative 2 to the 5th times that 8, which would equal negative 2 to the 40th power. Now I know that whatever negative 2 to the 40th power is, my answer is going to be positive because this number up here is an even number. You're pretty much going to use this same law for the rest of the exercises. So right now you can go ahead and finish up the front and then move on to the back, which has some different stuff on it. If you take a look, go ahead and flip over to the back so we can go over some of this stuff. If we have x to the y and x and y are in parentheses, and then we have an exponent, we can apply that exponent, go ahead and draw these arrows like I am, to both things inside of the parentheses. So this exponent applies to the x and it applies to the y. So you could rewrite it as x to the n times y to the n. So let's do some examples of this. Here in exercise 7, we have 11 times 4 to the 9th power. Of course, we could solve what's in the parentheses first and write 44 to the 9th power, but for purposes of practicing this law, we're not going to do that. We're going to apply, or distribute, if you remember the distributive property from last year, this exponent to both things inside of my parentheses. So that's going to be 11 to the 9th times 4 to the 9th. And I know I can't simplify this anymore because 11 and 4 are different bases, so I could not add these two exponents together. All right, let's go ahead and take a look at this one. We've got 3 squared times 7 to the 4th. And that product raised to the 5th power. Just like we did before, I'm going to apply this exponent to both things inside of my parentheses. But since these already have exponents, I'm going to draw a parentheses around it. So it says 3 squared to the 5th power times 7 to the 4th to the 5th power. Now, using what we learned on the other side of this worksheet, 3 squared to the 5th power is the same as 3 to the 2 times 5 times, here we've got 7 to the 4 times 5. And when we solve that one, it will equal 3 to the 10th times 7 to the 20th. We're going to do one last example that involves variables, and then you can be on your way to finish the rest of this. All right, here again our exponent is a 5, and here it doesn't look like we have two different terms in here, but one thing mathematicians do, I've mentioned before, is they leave out that multiplication sign. So since we have this number next to a variable, it means that we're multiplying 3 squared times a to the 4th. So we can apply this 5 and distribute it to both things inside the parentheses. So we end up with 3 squared to the 5th times n to the 4th to the 5th. And then again, we'll use what we learned on the opposite side of this sheet to do 3 to the 2 times 5 times n to the 4 times 5. That leaves us with 3 to the 10th power times n to the 20th. You'll notice I left out the multiplication symbol as well. This answer is correct, or if you included a multiplication symbol in between it, it would also be correct. Either is fine. Now that we've gone over the front and the back, go ahead and finish up this worksheet.